This is the solution to random MathStat problem number 185. In this problem, we're given a random sample x1 through xn IID from the Pareto distribution with a parameter gamma. We're asked to find the distribution of the minimum of the sample and to name that distribution. To do this one, we need to find the CDF for the original underlying distribution for each of the x's. The CDF for the Pareto distribution is the integral from 0 to x of the Pareto PDF. This is a simple power integral, and in the end, we get 1 minus 1 over 1 plus x all raised to the gamma, and this holds for x greater than 0. We're ready to go for the CDF for the minimum. The CDF for the minimum is the probability that the minimum is less than or equal to x. The goal at this point is to rewrite this in terms of the individual and original x's for which we know things. Let's look at a number line and put this fixed little x down here. How does the sample have to fall so that the minimum is below x? There are a lot of possibilities here. Some can be below x, some can be above x. Only one could be below x and the rest could be above x. They all could be below x. These are all ways in which the minimum would be below x. So this problem is easier if we turn it around and consider the complement of the event. The probability we want to find is equal to 1 minus the probability that the minimum is greater than x. And the data can only fall in one way, so that the minimum is greater than x. This happens if and only if every single one of the x's is greater than x. Because these random variables, capital X1 through capital Xn, are IID, we can factor this probability, and indeed is one probability repeated over and over again. This becomes 1 minus the probability that x1 is greater than x, all raised to the nth power. This quantity in here is 1 minus the original CDF that we found at the beginning of this solution. Plugging that in, we get this expression. Here we are raising something to a power and then to another power, and that means we get to multiply the exponents. So we get this expression for our CDF for the minimum of n IID Pareto random variables. Normally, we're not that good at recognizing CDFs, but we just saw this CDF on the previous slide. It didn't have an n in it, but this looks just like the CDF for another Pareto distribution. And in fact, we do have that the minimum has a Pareto distribution with the parameter gamma replaced by the parameter n times gamma.